The aggregation framework is super cool, but it is subject to certain limitations, and I want to discuss those with you right now so that you're aware of them. The first one is that the result set is limited to 16 megabytes of memory because, as you know, it's returned in a single document, and a single document in MongoDB is limited to 16 megabytes of memory. So that's pretty large, but for a very large collection, that could be a limitation if it's going to run across the entire collection. Another limitation is that you can't use more than 10% of the memory on a machine. Now, that's a lot of memory, but these aggregations can be quite complicated, especially if they're going across the entire collection. Now, you can reduce the size of your aggregations by doing early matches to do filtering if you don't need to do calculations across all the documents. Similarly, you could use project to filter out some of the fields so that you're processing less data. But these are two things to keep in mind. And the last one is how it works in a sharded environment. So let's go through a sharded environment. So in a sharded environment, if you remember, you typically have your collection, and we're not going to go over this extensively in this class, collection split amongst multiple Mongo instances. And these are often replica sets, so there might be 3 servers here, and 3 servers here, and 3 servers here that are all handling the same part of the collection. And then rather than send your query directly to a MongoD process, and these all have MongoDs running on them, you send it to a Mongo S process. It's a router, so your application is here, and it talks to Mongo S, which then talks to MongoD. And each of these is a shard. So aggregation does work in a sharded environment, but after the first group or the first sort phase, the aggregation has to be brought back to the Mongo S. So the first group and sort can be split up to run here on a particular. So if you're going to run an aggregation across the entire collection, the Mongo S will send that group and sort to all the shards, and it will do them. But after the first group and sort, they need to be gathered here in the Mongo S, brought together for a final result before they're sent to the next stage of the pipeline, because the next stage of the pipeline needs to see the finished result. So as a result, if you have a very long pipeline, you could easily wind up where your calculation is running on your Mongo S. Now, in terms of application engineering, usually the Mongo S process is running on the same computer as your application, so that your app is running, and then you put a little Mongo S on the same box, and that box might be sized differently relative to the database, might be smaller, and this aggregation might be gigantic. So keep in mind that when you're in a sharded environment and you're doing aggregations, that your calculation is probably happening in your Mongo S router, and that might have an effect on other application performance if Mongo S is co-located with the application. Kind of beyond the scope of this course, but I just want to mention it because I know that some of you probably do work in sharded environments on large production systems. And we're going to talk a little bit more about the implications of sharding and replication and other aspects of system architecture as a developer next week. Now, there are other alternatives to the aggregation framework if you don't want to use it or can't use it because of some of the limitations. You can use MapReduce. There is a version of that built into Mongo, and we haven't talked about it in this course, but you could use it. You could also use Hadoop, and the Hadoop framework is basically an implementation of MapReduce. And if you want to do that, there's a Hadoop connector that can connect between Hadoop and MongoDB. So those are some other options if you can't use the aggregation framework for a particular query. All right, so that's it.